Welcome to experiment 4. It's the vibrating strings experiment. We'll be looking at the propagation of waves through a string, a vibrating string. And we'll be using this implement called a sonometer, which generates a wave like this, and we can measure it on a cathode ray oscilloscope. So we'll be looking at the usage of a cathode ray oscilloscope. We'll be looking at the relationship between the frequency that we can measure on this with the length of the string. So we'll be able to change the lengths and see what happens to the frequency. We can change the tension on the string at the end here and see what happens to the frequency. And we can also change the diameter of the string, which will effectively change the linear density of the string. So as a guitar has 6 different diameter strings, they all have a different linear density, we can generate different frequency with a different string. So we're looking at those 3 relationships. So first of all, we're interested in the operation of the crow. So first of all, the first thing you're going to do is take the crow and plug it into your function generator. So the function generator basically puts out a sine, a triangle or a square wave at any frequency you like. You can change the dial here to change the frequency, and you can change this dial here to change the amplitude of the wave. So that's the two parameters you can control with this. Make sure that you plug the crow into the 50 ohm terminal on the end here. And yeah, you can adjust the amplitude of the wave here with this dial, or the frequency here. So you have a fine frequency adjustment here as well. And you have a range scale here. We'll be mainly working in the kilohertz range, so we can set it to there. So the first thing we're going to do is manipulate on our crow a signal coming from the function generator. So what we want to do then is, first of all, let's set up the crow. So there's a couple of things that I'd like to mention with the crow. You have a scale here. So on the vertical scale, basically we're seeing voltage. So each one of these divisions results from a certain voltage. And on this scale here, it's time. So we're basically graphing voltage as a function of time on the crow. So we can change the scale. We have control over the scale with these 2 knobs. So this one changes the time division, which is this division, the horizontal scale. And the vertical scale is controlled here with this one, so the voltage division. So let's get a signal on our function generator. So your notes tell you that we want to connect the waveform generator. We want to turn the crow, turn it on. So there's a switch which is just here to turn it on. We set our voltage division to 1 volt. So this is your vertical division here. Let's set that to 1 volt. You can see we've started to get a signal there on the screen. Now set the time division to 0.2 milliseconds. So we rotate this around to 0.2 milliseconds. So you can see that we have some signal there. So we set the internal trigger by this button to channel 1, which it currently is at. Now you'll see that we have these 2 knobs in the center of our time division and our vertical voltage division. And when I move these, you can see it changes the signal on the screen. So that's not actually changing the signal coming from the function generator. It's still outputting what you've set it to output. What that's doing is changing the scaling. So if we rotate it all the way around to here until it clicks into position, we're actually getting the actual reading from here for our time division. And also if we do it here as well. Rotate it, you can see I move that, it changes the signal until there, it clicks and it's calibrated. So now this is calibrated to an internal oscillator, so we can actually measure the signal that's coming out of here accurately with the scale. If these weren't correct, we couldn't do that. So let's calibrate it. Okay, so that's how it works. Now we can actually manipulate the signal that comes in there, not just what we're measuring, but the actual signal by using the amplitude adjustment here and the frequency adjustment here. So you can see as I change the frequency, the period, so remember this is the time scale, the period gets shorter, where the period is the distance between peak to peak or trough to trough. Okay, and this one adjusts the amplitude. So if you're having trouble with this so far, ask the demonstrator, make sure you talk to them they can help you. So if you don't have a signal on there and you can't measure anything, then talk to the demonstrator and they can help you.